Dear students, in this module, we will see that tests of adequacy of index number formula. We know that Fisher's ideal index, that formula itself we are calling it as Fisher's ideal index. There is a reason for that. The formula is satisfying time reversal test and factor reversal test. That is why it's known as ideal index number formula. So this is what we are going to learn in this module. What are the tests of adequacy for coming in the category of ideal index number? So this 3 tests are suggested by statisticians to prove that this is an appropriate index. One is time reversal test, second one is factor reversal test, and third one is circular test. First two methods, that is time reversal test and factor reversal test, are widely used, and circular test is not that in practice. So we are concentrating our explanation on the first two methods, that is time reversal test and factor reversal test. So time reversal test, first I am going to tell you the theory, the statisticians how they will express this. So time reversal test is this is the test to determine whether a given method will work both ways in time, both forward and backward. That meaning, simple terms if I'll tell you, we know that if you are taking 2021, that is the current year, the base year will be the previous year. In our examples, we're using 2020 as the base year. That meaning 2021 as the current year and 2020 as the base year. Now we are reversing that. That meaning 2021 we are taking as the base year and 2020 we are taking as the current year. When I'll explain that, I will explain that how we will change the formula. So even if we will do that, if we'll change both words both ways, that is forward and backward, that means it will work always in time. That means it will prove that the value is 1. That is what we are going to explain. So if a data for any 2 years are treated by the same method but with the bases reversed, that is why I am telling you current year we are taking it as base year and base year we are taking it as the current year. The two index numbers secured should be reciprocals of each other so that the product is unity. That meaning it's 1. If we take the words of Professor Fisher, the test is that the formula for calculating index number should be such that it will give the same ratio between one point of comparison and the other, no matter which of the two is taken as the base year. That meaning current year and base year we are changing. Now you have to see that tests of adequacy, symbolically P01 into P10 is equal to 1. That meaning, let us see how we will satisfy the Fisher's ideal index is satisfying this. P01, that meaning the first 2020 we are taking as the base year and 2021 we are taking it as the current year. The equation will be sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1. Now what we are going to do is we are changing that. 2020 is our current year and 2021 is our base year. Now how we will change this equation? See, wherever we are getting 1, that meaning current year we are changing it as base year. So the equation will become P0 Q1. So it's very simple. First one it's P1 Q0, that we are changing to P0 Q1. Similarly, P0 Q1 divided by P1 Q1. All these values are changed. Wherever we are getting 1, we are changing it as 0. Wherever we are getting 0, we are changing it as 1. So that is sigma P0 Q1 divided by sigma P1 Q1 into sigma P0 Q0 divided by sigma P1 Q0, and we are taking the square root of that. Now we have to see that how Fisher's index, we are going to check that whether Fisher's ideal index is satisfying this test or not. So I have explained that how we are getting P10 values and P01 values. Now we are writing both the equations, how we obtain by converting 1 to 0 and 0 to 1. And the first equation will be the base equation, that is the Fisher's ideal index number. So when we are taking that values, we can see that common values we can cancel it. So that is why we are getting root 1. The effect will be root 1, that is equal to 1. That means Fisher's ideal index is satisfying the time reversal test. Now the second one is factor reversal test. This test holds that the product of a price index and quantity index should be equal to the corresponding value index. That meaning P01 into Q01. That should be sigma P1 Q1 divided by sigma P0 Q0. Now what we are going to do in this conversion in the formula, wherever you are getting P, we will substitute it as Q, and wherever you are getting Q, we will substitute it as P. That is, we are changing. the price index and quantity index we are interchanging. Then we have to see that whether it is qualifying the test. So remember that the product should be equal to the value index, that is the P1 Q1, that is the current year price and quantity divided by base year price and quantity. Now, according to Professor Fisher, his words, just as each formula should permit the interchange of the two times without giving inconsistent results, hence it ought to permit interchanging the prices and quantities without giving inconsistent result, that is, the two results multiplied together should give the true ratio, that is sigma P1 Q1 divided by sigma P0 Q0. Now, tests of adequacy. The first equation is the basic equation for computing Fisher's ideal index. That is square root of sigma P1 Q0 divided by sigma P0 Q0 into sigma P1 Q1 divided by sigma P0 Q1. Now, we are substituting the equation. Wherever P values are there, we are changing it as Q values. Wherever Q values are there, we are changing it as price values, that is, or the P values. So Q01 value is sigma Q1 P0. That meaning, see that basic equation, it's P1 Q0. Now, instead of P, we are writing Q. Instead of Q, we are writing P. That is how we are calculating for all the values. That is sigma Q1 P0 divided by sigma Q0 P0 into sigma Q1 P1 divided by sigma Q0 P1 and the square root of that. So we can substitute these two equations, that is P01 into Q01. When we substitute the equations here, we can see that common values we can cancel. Then we will get square root of sigma P1 Q1 divided by sigma P0 Q0. So when we will take that we will get sigma P1 Q1 divided by sigma P0 Q0. That is current year price into current year quantity divided by base year price into base year quantity. Thus, Fisher's ideal index is satisfying the factor reversal test also, because this is the value index. We have changed price with quantity and quantity with price. We have interchanged that. So, Fisher's ideal index is satisfying the factor reversal test also. And you have to remember that Fisher's ideal index is the only index formula satisfying the factor reversal test. So, I told you, if you want to call an index calculation as the ideal index method, formula has to satisfy both time reversal test and factor reversal test. And in this module, we have proved that Fisher's ideal index number is satisfying the time reversal test and factor reversal test. So this is what I want to explain in this module. Thank you.